This time I got a Sony KV24FV300, but this is the BA6 chassis, 2002, one of the last of the analog chassis that Sony made. This one is totally dead. Let's see what the problem is. Today I have a Sony 24-inch Trinitron. Press the power button. Let's watch. It's dead. Let's watch the blink code. Okay, power on. Let's count them together. Okay, now it shuts down. 4 blinks. 4 blink code on Sony is typically a failure in the vertical circuit. So let's get the back off this one and see where the problem is. Remove all the screws and the back will just lift off. First thing I'm going to do is I'm going to inspect the board for any cold solder connections, because Sony's were notorious for cold solder connections out of the plant in Mexico, which is where this one came from. The catch up at the front, you just have to pull the catch over a bit and then the circuit board will slide out so that I can tip it up on its edge, and we'll unplug this plug here. I want to be able to tip this thing up just so I can look at it. I'm just going to push the TV a little bit more forward on the bench just so that I have a little bit more room to work on it. I want to flip the board up on its side so I can inspect and see if there's any connections or anything on here that have been damaged or gone bad. Oh, look at this. Yeah, looks like there's a crack in the board right there. I wonder if that's all that's wrong with it. I bet it's not. But for starters, that could certainly do it. There's a crack in the board right there. I can see it. I wonder how bad it's cracked. Well, let's just make ourselves a little bit more room here, so I can prop this board up on its side, out of the way. Alright, so someone's done a lot of work on this. They've been into that horizontal output. This set has been repaired before. Take a look at this area down here of the board. Look in here. You see where I see there's a crack right there. You can see where it's been burning. There's a crack right across here. I wonder if that's all that's wrong with it. It's possible that that's the only damage, or is that crack on both sides? It looks like there might be another one down on the other side of the board here too. If you look down this side, this would be right where the board is separated between the front and the back. It looks like there might be another crack right down here, if I can see it. Where are we here? Right there. Looks like there's a crack right there on the board. Damn. Well, that should be repairable, I would think. Well, this one's definitely arced. You can see the discoloration. The question is, has other damage been done when it arced? Did something else get blown out? The owner of it said that they plugged it into a component signal, and they were testing it with component, and it made like a popping sound and went out. So it may have been just the crack opened up here and arced a bit, or there may be other damage. First things first though, I got to remove the paint off the board here and see where that trace goes, and we'll do the same on the other side. We'll repair the damaged trace. Hopefully it hasn't blown anything out, because there's a lot of parts in here that you're never going to get, right? Like this is your horizontal control. There's a little IC down here, and that's right near where it's cracked. The crack is just behind here. So hopefully it hasn't blown any of these parts out, because things like that, those parts, you're never going to find them. Not today. This thing is so old. You can see the other crack. And how far that crack goes, that is the $64,000 question. how many traces are severed on here. Looks like there's a few. Looks like it goes all the way down to about there.
You can tell this is a cheap TV. It's using a cheap paper and epoxy type board, and they are quite fragile.
Oh no, it goes all the way down to here. You see the crack right down through here as well. Look. Take a close look. You see the board crack? Cracked all the way down here. Well, I guess first things first, I'll try to repair that crack. See whether the TV will turn on. Now generally when I see damage to boards like this, it is a pretty good indication that the TV probably fell over. It probably fell forward, either fell off a stand or tipped over in someone's vehicle, or fell over, and the resulting shock of the board flexing damaged it. So the question is, what's happened to the CRT? Has the aperture grill been damaged? Because these Trinitrons are very prone to the aperture grills being knocked out of position on them. So first things first, I want to see if I can get the TV to start up. But see, we got breaks across multiple traces here. Now some of these ones may not be critical. Some of them may only affect certain operations like the tuner, which we're not really too worried about the tuner. More concerned about getting the TV to start up and see if there's any other damage that's been done besides this. Okay, let's just look on this other side. This is the side that you can see where it's burned. And it was charged too. Power supply was charged. Well, that would explain why. No, I did not get a shock, by the way, but that capacitor was charged on this thing. That would explain why it's not working. The B plus was gone. So, it's discharged now, that's for sure. Obviously that B plus cap was charged, so at least we know the power supply works. It's a good sign. Anything else? Any other surprises on this thing for me? Typically the voltage is going to drain down pretty quick once the power is removed. But if the lead coming off of the power supply is severed and it's disconnected from the output, then there's no place for the high voltage from the power supply stored in capacitors to dissipate. Clear this off and fix it. Good thing I was recording there to give you guys a scare. And it looks like this one's just in this area here, which is good in the horizontal output. We'll actually bridge a wire across this one. We always resolder the horizontal drive transformer on all these sets, no matter what, because they cause so many problems. Horizontal drive transformer cracks. This one hasn't, but it does on a lot of them, and then it blows the output transistor. Looks like the flyback's been resoldered on this one too in the past. That looks like it's been done. Somebody did that. See, this set's been worked on because that output transistor has been changed. I was looking to see if I see any other connections that look flaky. Do an inspection before I put the board back in. We'll attempt to power it up and see whether it works. No power. But we have no B+. So we'll disconnect the output transistor and see if the voltage of the power supply comes back. See, what I don't know is if this is even an original transistor or whether someone subbed it. It's obviously been changed before. 2SD2634 is what this one is. Test it on the circuit. It should be shorted. Oh, it's not. Okay. That way it is. Though most of these have a damper diode in them. Oh yeah, it's bad.
Actually, it's not bad. I tested a couple of other equivalent transistors I had.
See?
And they measure the same.
Emitter to base is shorted.
The transistor has an internal emitter to base resistor and a damper diode. So on these ones you will get what appears to be a short.
0.4, that'll be the damper diode. Alright, damper diode internal. But 0.4, that's emitter to collector. Should not be doing that. That should be, well, that's the damper that way, so that might be okay. But NPN, that should be like a 0.6. That's a base to emitter.
Nope, perfectly normal on these ones. It has an internal resistor.
See, it should be like 0.5, 0.6. Alright, so give it power. I should have B+, and I don't. So we have more issues than just that. we may have a problem back here on the power supply as well, because I still have no B+. If we look over at the scope, this is scoping the outputs from the chopper going into the transformer for the power supply. And you can see that the power supply does attempt to start and then shuts down, which indicates that the drive IC, IC600, Q600 and Q601, the chopper transistors are good. That was scoped right here on the input to the transformer. If we look at the DC voltage on there, we should probably have about 300 odd volts, or somewhere thereabouts. That's what the primary on this is operating. It operates using a voltage doubler circuit. So if we look at the primary, it should be somewhere in here. When I turn it on, measure the DC voltage, and where are we here? Well, our B+ is over here, 328 volts coming off the rectifier. And that voltage goes over to here, which ends up on our chopper transistor, and it will end up over on this transformer. But we have oscillation. There's another crack back here on this set. I don't know whether this one's going to be worth repairing or not, because when you get a cracked board, you just don't know how far the damage is spread on here. I should see my B+ coming up if the MOSFETs are working properly. And I see a signal. I see a signal going in. When I flip the power on, watch the scope. Okay, so that's 50 volts per division. That's the source for the chopper. So it's coming on. We've got nothing on the secondary. May have a short in that secondary somewhere else. Just gonna go through with my meter and see if there's any of the diodes are shorted, because I'm not getting any B+, and I should be with that kind of voltage. That's like almost 300 volts across the transformer going in. I should see something on the secondary, and I'm not. So if we remember, this is where it was the board was broken before, and there was a cap that was charged, which shouldn't have been charged because it wasn't plugged in or anything, and these other ones discharge almost immediately when the power is removed. When the switch is off, these other primary filters, they discharge fairly quickly, like within a couple of minutes. But because the circuit board was cracked here, there was an open circuit. Something was holding a charge, and it may have blown something up there. Let's just look and see if any of these diodes are cooked in the secondary side here. It's just the way it's behaving. It's like, well, let's just see if there's anything else that's shorted in here. Oops, that's not what I'm looking at. Oh. Okay. Oh, that's across the transistor. That's across the transformer. That's okay. That's fine. I was looking across the winding there. That one looks to be okay. What about this one? That's across a winding. That, I wonder if that diode shorted. Somewhere in here we got a dead short shutting this power supply down, and my B plus isn't coming up at all. I may have to blow up the schematic a bit just so I can see it. I can see it on the computer screen. If I go and look on the computer, I can blow it up on the computer. But it's not ideal to work off the computer screen. Oh, that diode is shorted. Right there. Okay, so that diode is shot. What else is wrong with this thing? Could be a few things. I would just like to get the B plus back. If I can get the B plus back, then we've made some progress. And at this point, I don't even know whether the owner of the set is going to want to spend some money on this thing, because again, you can generally find these TVs for not that much money. Shorted. That diode is a 150 volt Zener. It's a protection diode. We can power this setup without it. See whether the B plus comes back. That would explain why it was shutting down. Let's see if the B plus comes back without it. Let's just take a look at our 135 B plus and power it up and see if the TV turns on. Oh yeah, 135 volts, see? So our 135 volt supply is good now. So see? Power supply is working. I think that transistor does have a damper or internal resistor. I've got another one here. I got a 2SD1650, which is a similar transistor. If we measure it, okay, there's our base to collector, base to emitter. Looks like it's got a short, right? And of course, it's got a damper diode built in as well. There's a damper diode, but you see, more importantly, 0.064, and here's our questionable one of this TV. So I'm just putting some more heatsink compound on the back here. Nope, shut down again. 4 flashes. We'll check and see if we get any horizontal deflection. Nope. Holy crap. So the regulation's been lost on this. That was measuring 130 volts. 135 volts before. Now it's shooting way up to 240, even without the output transistor in. It was starting and shutting down, so I pulled the transistor. The transistor is not damaged, but this thing's starting up way too high in voltage now. There's got to be another crack somewhere on this board that I haven't found. And that is convincing me that this set was either fell over or was dropped or something. But I'm going to get a hold of the owner of this set. I mean, a 24-inch CRT, you can get these things pretty reasonable. Even at this point, they're into territory of buying a used set. But we still have problems on this thing. The high voltage is shooting so high. That's why this Zener diode is 150 volt. It basically, it's a crowbar. It shorts out if the voltage goes too high. That's to protect you from getting X-rays, because if the TV were to fire up and the over voltage protection didn't shut it down, the CRT would emit X-rays. So they put a Zener diode right across here to kill the output if the voltage goes too high. I'm just going to take a close look in the feedback circuit and make sure that there's not a bad connection on the photocoupler in the feedback circuit, because that's how they monitor the voltages. They monitor the voltage through a optocoupler right here. We'll check a look at that and see if the connections look okay on that. See if we can get a close up so you guys can see. Does this look okay to you? Oops. I mean, the voltage was correct, and then it shot up. That one there looks like it might be bad. Let me just redo those and see whether the voltage comes back down to where it's supposed to be. Because this provides feedback. The little LED lights up, and the brighter it is when the voltage is high, and then that provides feedback that comes back down to this control IC. So a couple surface mounted caps or resistors, and it comes up here. See, it's right up into this circuit where that crack was, so the crack might even be right in here still, because this feeds right through to here. It goes right in through there. So I'm just going to give a close. You guys can't see what I'm doing because I'm not framed for you guys. Let's just frame that again. If we look at the optocoupler, if we follow it up here, where are we here? Optocoupler comes up and it goes through here and it comes along through here and it ends up right in this area where the crack is. So I'm just going to take another real close look and see if there's not another crack in there, because that certainly could. That's where it picks up its feedback for the voltage regulation. So if there's another hairline fracture in there that I didn't see, that could certainly explain why the voltage is shooting up like it is. Just going to resolder, put a bridge over here, right in this area. See if the voltage will come back down to where it belongs. And yes, I will be replacing the Zener. I don't have one, but I'll get one if I can get the set to work. We'll just measure that voltage again and see whether the voltage goes off the end of the scale after soldering this up. It should be 135 volts is what it should be. So let's just measure the 135 as I plug it in and power it up. So we should have 135 right there when I turn the set on. 135. That's what it's supposed to be. Okay? Let's put the horizontal output transistor back in and see if the TV will fire up. Let's see if it'll turn on this time, or there's something will go boom. Still not turning on. And it's flashing that 4 blink code. 4 blink codes indicate a vertical problem, like the vertical output IC is shot. Watch it be toast. We'll just see whether I get any horizontal drive. I'll just flip it on its side here. We'll clip the scope on and see whether there's any horizontal drive. no horizontal drive. Go back to the drive transformer and see whether there's any drive on the horizontal drive transformer, because the horizontal output's not kicking in. And which one of these is the drive transistor? Okay, let's look for horizontal drive. Looks like we have horizontal drive. That part's working. Okay. So, why don't we have any output? Are we not getting a good connection to the base of the transistor? Okay, resolder the base. Still nothing. Are we getting anything on the base? Let's just scope the base and see if there's anything on the base itself. Actually, I can scope the output of the drive transformer. We know we got signal going into the drive transformer. We've got signal coming out of it too, it looks like. Yep. So why do we not have any triggering that base? Goes through a resistor. My voltage is there, my drive is there. This set should be turning on. Okay, I've got drive, right? That's the original transistor, but I still have no output. Is my voltage there? Let's just see if I've got voltage on the collector. 135 volts. I got no output. Collector, or sorry, the emitter is grounded. So I got my ground probe, or a probe on ground. In resistance mode, if I go to the emitter, 56 ohms. 56 ohms. 1 ohm. We have a crack right here. Right there, there's a crack. I cleaned up the board. This was worked on long before I saw this TV, because I think you guys saw the mess that it was. There is a crack right there. Right around the rivet on the emitter. What do you bet it starts this time? Where's all output? I'll just dial back my scope in anticipation that this freaking thing is going to start up. Start, you bastard. Ah! I got power! Alright. Let there be power, folks. CRTs, I love these freaking things. God damn. Let's see if this thing's got a picture. Well, we have a picture. We don't have a good picture. It has severe, and I mean severe pincushion distortion. That could be still a fracture on the board. It could be another broken trace, or somebody could have been messing with the settings. But there looks to be no pincushion correction whatsoever. Yeah, it looks horrible. You know, and again, at this point, I'm going to get a hold of the person that owns it and say, look, you know, I spent a bunch of time on it fixing up the cracks on the board that I could see and got it running, but it's got a really badly distorted picture. How much money do you want to spend on this TV? At this point, it's beyond economical to get into this thing and start playing with it. And I mean, somebody could have been into the service menu too. See if I can remember how to get into Sony. It's been so long. Display 5 volume up power, I think is what it is on Sony. It's either volume up or volume down. You gotta find the display button on this remote. Display 5 volume up power. I think that's the command. It's either display 5 volume up power or display 5 volume down power. There it is. Okay, now if I can remember how to do this, deflection, horizontal size. I mean, there's noise in the picture as well. Horizontal position, vertical size, vertical position, vertical linearity, vertical bow. Vertical angle. See, somebody could have been playing around with this too, right? Pincushion amplitude. I think that's P amp. Pincushion doesn't appear to be having any effect on it at all. Lower pin. See, this is not making any changes. So we have a problem. Pincushion correction circuit is not doing anything. I won't write this to memory. I'm just, because you have to go. It's a 2-step process, so I can screw around with this all I want and just turn it off, and it'll go back to what it was. But you know, as you can see, it's you know, it's not making any effect whatsoever. The pincushion's not doing a thing. There's a 16:9 settings. Deflection, pincushion amplitude. It's not making any effect. So I got to look at the pincushion circuit on this now. I got to get a hold of the customer that owns this one and just let them know, okay, I've got it working, but the picture is like crap. It's I'll take a look at the schematic too and see where the pincushion circuit is. Maybe it's just a connection. But we're most of the way there. We got a picture on it now. It just doesn't look right. I'm just going to spend a little more time and just stare at the board here and see if I can see any connections that have failed, any broken solder connections, or any more cracks in the horizontal deflection circuit in here. Because to say the pincushion correction is not working, nor is the horizontal width. I have no control over the width or the pincushion. So it could be just a bad connection on the pincushion transistor or somewhere here. So I'm just going to really just look at this kind of closely and go over anything that looks like it could be questionable and see if I can spot any more little cracks in here, because this is where the damage was right here. So I spoke to the owner of the set, and they're kind of leaning into not repairing it because they didn't want to spend more than $100 on the set, and you know, for the amount of time that's been spent on it already, we're there. So I guess I've lost my shirt on this one again, and I picked it up. So yeah, I've lost my shirt on picking it up, and I've lost my shirt on the repair because you know, I've spent a couple of hours on this thing. Actually, I've spent several hours. I've been on it probably for about 4 hours to work on this one. So I guess, you know, you can't win them all, but I certainly think that the set has probably been dropped at some point. Hey, it would be good for monitoring security cameras. That's about it. And I should plug my Pac-Man game into it and just see how bad it really looks. Should I do that for fun? Yeah, the input on the front works, so there's obviously another crack on the board there somewhere. So, some games look okay on it. But that's all we're doing on this one. Thanks for watching.